So we're going to go ahead and start our next section, 4.4, which is about concavity and the second derivative test. So just like the last section, we're going to start by defining what concavity is. So let's start there. The graph of f is concave upward on I when f prime is increasing on the interval so to be concave up, your derivative needs to be increasing, and it's going to be concave downward on I when f prime is decreasing on the interval. So again, I want to help you kind of visualize what's going on here. So let's look at a graph that's concave up. So here it's concave up. And then over here, I'll give you a picture of a graph that's concave down. So what I want you to do is think about the tangent lines on these graphs at any given point. So if I take a point here and draw the tangent line, there's my tangent line. Here is my tangent line. Here is my tangent line. Notice that your function f lies above all of its tangent lines. And if you look over here at concave down, if I draw at any point my tangent line, that was a really bad line, sorry. There we go. Your function is always going to lie below. F lies below all of its tangent lines. Okay, so now that we know what concave up and concave down mean, and we know how to visualize them, let's talk about how you're going to test for concavity, how you're going to determine is a graph concave up or concave down. So we're going to suppose let f be a function whose second derivative exists on an open interval I, and if the second derivative is bigger than 0, then the graph is going to be concave up. Then the graph of f is concave upward on I. If your second derivative is less than 0, we're going to say that then the graph of f is concave downward. So again, I'll underline the most vital pieces is that if your second derivative is bigger than 0, if it's positive, it's concave up. If the second derivative is less than 0, if it's negative, your graph is going to be concave down.